Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here coming with another fantastic chemistry video, and today we're going to talk about naming cyclic alkanes. Very simple, very fun, but common on exams. So let's learn how to do it and do it correctly. Let's do the one here on the left. It's a simple cyclo system, just a monocycle. It's got 6 carbons, 1, 2, 3, 4, 5, 6. So that is a cyclo. We have 1, 2 substituents, and they both happen to be methyl. So 1, 2, 3, and 4. So we have a 1-methyl and a 4-methyl. Okay, very simple. Now, when we put it all together, we would get 1, 4-dimethyl cyclohexane. And that's almost correct. We're missing the stereochemistry. We have 1 methyl going down, the other one is going up. That's a trans relationship. So it's trans 1, 4-dimethyl cyclohexane. That's how you would name that particular one on the left. Very, very simple, but fundamental. Make sure you get that stereochemistry correct in the front. That's a very common thing students neglect to do. So let's do the center one. So now we have a bicyclic system, and bicycles are always named the same way. It's going to be bicyclo, open square bracket, 3 different numbers separated by periods, close square bracket, and then the root name of the bicycle. So the first thing you have to do when you have a bicyclic system is count the total number of carbons that are involved in the bicyclic system. So here we have 1, 2, 3, 4, 5, 6, 7. There's 7 total carbons in the bicyclic system. So that's a heptane. Okay, so it's going to be bicyclo, square bracket, some numbers, close square bracket, heptane. But how do you know what numbers to put where? How do you know how to figure this out? Well, what I tell students to do is the following. Write bicyclo, open square bracket, close square bracket, heptane. So now all you have to do is fill in these blanks up here. All you have to do is fill in those blanks. Well, what do we put in those blanks? Great question. To fill in those blanks, we have to know how many carbons there are going in 3 different directions around what are known as the bridgehead carbons. The bridgehead carbons are right here and right here. Those are called bridgehead carbons. They're where the 2 rings come together. All you got to do is count in 3 directions from the bridgehead, from one bridgehead to another. So we're going to count from this bridgehead around this way back to that bridgehead. We're going to count from this bridgehead around this way to the other bridgehead. We're going to count from this bridgehead this way to the other bridgehead. We need to tell the reader how many carbons are there between this bridge and this bridgehead carbon. That's all we're going to do. So now, 1, 2, 3. Bridgehead, 1, 2, 3, bridgehead. So put a 3 right here. So from this bridgehead to this one, going in this direction, there are 3 carbons. So now, from this bridgehead over to that one, going this way. Bridgehead, 1, bridgehead. So the number 1 goes here. The biggest number always goes in front. So 3.1. So starting from the bridgehead, going up, bridgehead, 1, bridgehead. So only 1 carbon separates them in this direction. So put the number 1 right there as well. So it'll be bicyclo, open square bracket, 3.1.1, close square bracket, heptane. That's how you would name that particular bicyclic system. Okay, so that's how you name. And all bicyclos follow the same rules. So there's monocycles, bicyclos, and now we have what are called Spiro cycles. So to name this one, it's the same kind of idea as naming a regular bridgehead bicycle, except for now you'd say Spiro. Open square bracket, close square bracket, and then you would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would say decane here. It's going to be Spiro something decane. Now, in a Spiro cycle, you don't have two bridgeheads. You only have one. So there's our bridgehead right there. So from that bridgehead, we have to count one ring and the other. So we would go bridgehead, 1, 2, 3, 4, 5, back to bridgehead. So it's going to be 5, decimal point. From this bridgehead, 1, 2, 3, 4, 4. There we go. So Spiro, 5.4 decane. And that's how you would name that particular Spiro cycle. All right, guys, if you found that video helpful, please go ahead and slap that like button. Leave a comment down below. Tell me how I can help you out in organic chemistry. Give me some ideas for videos that will be beneficial for you. And if you could, please share my content with anyone that you know who's taking organic chemistry right now or may in the future. Hopefully my content can help them as well. And if you could, please subscribe to my YouTube channel. It really does help out YouTube creators when people subscribe. It lets YouTube know that our creations are good and that people are engaging with it. And with that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.